Okay, dear students, now we'll go to another concept in the linked list, which is the doubly linked list. Okay, so doubly means that you have two pointers in your node. Remember in before we had only one link, right, that we called link, or we called it later next. So the node was divided in two parts. It had only the data part and the next node. But now in the doubly linked list, we have two nodes. We have the front or the next link and the back link. Okay, you see this first here, it will point to the first element in the node in the list, which is the first node here, and the back back pointer here in this node will point to null because there is nothing before it. Okay, and this one will point to this next node, this one to this next node, and this one to this next node. And the you see that I have next and I have back. I have two pointers. So the node will be divided in three parts. So the data structure will be a little bit changed. So instead of having only, let me go to the code. I will show you how we do that. So here in the code, remember, I had the data and I had the node next. So now I will not have only the node next, but I will have the node back. Okay, so which is similar to the same type. Here in my code, I called it node structure, but in the book they call it node type. It's similar. So you see here, this is the extra thing that I added in the code. Let's go back to the book here. So the same thing here, like he's using templates and node type of type next, and you have back. Okay, so all the operations are similar, but of course there will be some differences in the deletion and in the insertion, of course, of the nodes. Okay, so let's go to the length of the list is the same, printing the list is the same, but we have two types of printing. We have printing when we go just next, so we use the current pointer and we start with first, and the while loop. Current is different from null, so we just print the info. In our case, we'll just do like this. Let me show you the print. So the print is like this. I use temp instead of current, and I had a while loop. Okay, so I will create another one, another print. So here I will call it print reverse. Okay, in the book they call it let's see it. Yes, reverse print of the list. So here, basically, you will not start from the first, but you will start from the last node. Okay, this is the difference. And you go next. So instead of putting next, you will do back because you want to go backward. Okay. So here I will say I will call it current. So to be similar to the book, current pointer, and I will say current is equal not to first, but to the last element. Okay, so the last node. So here I will say while current is different from null, I will print the data. So if it is not null, I will print the data, right? And here I will say current, right? So let's copy it. So I am just using the current as a temporary. I will not say next, but I will say back. Okay. So here, this is the reverse print function. So this was the print function where you just print. Let me just delete so I can show you both functions. So you see the difference between the two. The first one is you start with first and you go next, and the second one, which is print reverse, you go backward. Okay, so you will go from the last and you go to the first until you find the last element, which is really the first element, and you will print backward. Okay, so here when you create an element, so first and last are similar. There is no no changes. The length will be the same. Get head will be the same. Get last will be the same. Print, we said we have 2 prints. Okay, search, like this is like searching in from the front, from the beginning to the end. Okay, and here when you create an element here, when you create an item, you just don't use only next, but you need also back, right? So you have to be really careful when you insert an element. I will not do the code for you, but you will go through it by yourself. So let's see, in the book, they have the code, but of course using templates. In our example that we coded, doesn't have templates. You see here, it's the same thing. We just do the front search, okay? We are going from first to last. So search will not change. First will be also same, and back is a new function. So basically, you will just assert that this is the last element that you have in the list, okay? So insertion in a node is similar to the previous case that we said, but you have to be really careful because now your list has 2 pointers. It has the front, which is called next, and the back, which is called back. Okay, so when you insert an element, you have to be careful. Let's see some examples here. For example, I had 15, 24, and I want to insert an element between 15 and 24. So let's say element 20. So what I will do in my code, I will create a new node, right? And I will assign the data in that node, let's say 20, and then the next will be pointing 24. The back of 24 will be pointing my new node, and the back of the new node will be pointing 15, and the next of 15 will point 20. So I have 1, 2, 3 pointers to take care of. So you have to be really careful when you do your code, okay? So of course you have always to have a pointer that will help you to get the node that is before your current, okay? So if a first is equal to node, I don't do anything, it's similar, right? But here, this is where when I have the other case, this is the one here, okay? So when I have to use back here and there, okay? So you have to take the code that I wrote and change it and add the back pointers here. You have to be really careful. And the best to do it is really to draw the lists by your hand and take notes of the before. So remember, this was the current pointer, okay? The current will point this node, and the trail current will point this one. So if I have trail current and current, it's easy to set the pointers, okay? This is the code in the book that you can just take and rewrite in the code that I just showed you. For delete item, here I have also a list, and I want to delete an item. The item can be in the middle, or can be in the beginning, or at the end. So remember, we did it already in the code. So let's suppose that I arrived to the node that I wanted to delete. So I did the search for it, and it is pointed by current. And the one that is before, it is pointed with trail current, right? So this node, I need to delete it. So what happens? What should I do? The current.next, which is this one, I will take the back of it and I will point it to trail current dot back, okay? Dot next, sorry, dot next. So dot next, trail current dot next will have the back of 44, which is current dot next. And I finished with this. And this one, trail current next, will have the address of 44, which is the current dot next, okay? And of course, the current, I need to delete it. Don't forget that. So this is the code here. So if first is equal to null, I cannot do anything. The list is empty. If I found the node and it is in the beginning, I just need to change the current. I will assign it I assigned first to current, and first will be first dot next. Okay, so if first is different from null, so it has something before, I will have first back is equal to null and last is equal to null, and of course I will do count minus minus and I will delete cannot. So this is the code for the delete. Okay, so you have to be really careful with the delete and the insert in a doubly linked list. So what I suggest again, and I repeat it again, is that you draw your linked list and you check all the possible cases that you have. Remember the cases that we have an empty list where we want to insert an element or delete from it an element. So this is the simplest case that we need to start with. Later, we have a list that I want to add in the beginning or delete the beginning, or delete the end and add the end, or the worst case scenario is that I would like to insert an element in the middle, or I want to delete an element from the end. So this is the doubly linked list. We have another topic that we will skip, which is the containers. I will not do it, but we want to know also about circular linked list. Circular linked list is basically the last element should point to the first element. Okay, this is called circular linked list. So you have here, this is a list that has only one pointer to the next node. So the node is having two elements. So this is like the first case here. I have three cases here, right? I have A, B, and C. The first case is when I have an empty circular list. So first is just null, or it has only one element. So this element here is pointing to itself. Okay, so the next will point to itself to point to first. So this is like circular with one node. And here I have circular with more than one node. Okay, so I have the first element pointing to this element, which is pointing to the last one. Okay, so this is really cool to work with. And you can do the exercises from the book. Programming exercise number 13 in the book will show you how we use circular linked lists. Okay, so we are done with the with linked lists, alhamdulillah. So we did a lot of things with it. So what I want you really to do is really listen to the videos and do the exercises, do the lab. And if you have any questions, please don't be shy to ask questions. Okay.